Let's continue our journey, and in this episode, we are going to discuss more about the network security. With today's complex network architecture and constantly growing networks, protecting data and maintaining confidentiality plays a very important role. Complex networks consist of data traffic flowing between enterprise network, data center networks, and of course the cloud as well. A secure network helps us to protect against data loss, cyber attacks, and unauthorized access, thus providing a better user experience. Network security technologies equip multiple platforms with the ability to deal with exact protection requirements. A firewall serves as a crucial network security tool by controlling traffic flow based on predefined rules and policies. Its placement within the network architecture varies depending on the need to safeguard different areas such as network, perimeter subnet, and zones. Perimeter firewalls are positioned at the network edge to filter incoming packets, and that is going to be your first line of defense. So let's say if this is the host and this is part of some subnet and this is my router which is connecting to outside world. So here you're going to place your firewall. This is going to be the firewall and this is going to be called as a perimeter firewall. In case where malicious traffic breaches this layer, host-based firewalls offers an additional safeguard by regulating traffic to the individual and host devices. And those host-based firewall can be directly installed on these hosts. This layered approach, known as multi-layer security, enhance overall network protection. To further fortify security, organizations may deploy multiple firewalls. So let's say you have Jones and this is DMG. You can put another firewall to protect this particular zone. This is going to create a high secure environment. Beyond perimeter defense, firewall are also strategically placed within the network to facilitate segmentation and safeguard data within enterprise infrastructure, including access layer and data centers. Firewalls can be further classified as following. The first one is going to be the simple packet filtering. Second is going to be the application proxy. Third one is a stateful inspection firewall. And the fourth one is a next generation firewall. A traditional firewall basically provides a function such as packet address translation, PAT, and PAT is needed when you have a firewall like that. And this is your LAN segment. In the LAN segment, you might have multiple hosts, and when they try to connect outside to the internet, all these IPs on the subnet can be mapped with the public IP address which is assigned to firewall, and that functionality is basically called PAT. If it is a 101 relation, you can also call it NAT, and you can also use this firewall when there is a remote user which is trying to do the VPN into this network. In simple packet filtering, you can quote a router device where each packet that enters or leave network interfaces is examined against a set of rules. And these rules are called ACLs. And the decision is made whether to allow or to block that particular packet. Typically, the rules specify criteria such as source, destination, protocol, and sometimes packet content. And these ACLs can be applied on that particular interface in a particular direction, whether that is going to be in or out. The next type of firewall is going to be the application proxy. Think about a web proxy server. A web proxy acts as an intermediary between the client, and when I'm referring to a client, consider all these requests are coming from your web browser and the web server on the internet. So what will happen? A client is going to initiate a request from the browser that will be intercepted by your proxy, and proxy is going to initiate further connection or a new connection to requested website. After inspecting all the content and filtering control, a response will send back to the client. Since I quoted this equipment as a proxy SG appliance, this is nothing but a Blue Coat proxy, and this is owned by Broadcom now. And it also gives you some more capabilities, which includes content filtering, SSL, interception, web caching, your authentication and access control. You can also do the bandwidth management and malware protection. The third type of firewalls are going to be the stateful inspection firewall, and these firewalls are also known as dynamic packet filtering firewall, are a type of firewall that monitors the state of active connection and makes a decision based on the context of the traffic. Unlike traditional packet filtering firewall, which examine individual packet in isolation. Stateful inspection firewall maintains a record for a state of each connection passing through them. The example you can quote Cisco ASA firewall, Checkpoint firewall, and Juno's SRX firewalls. And here in this example, you can see in a stateful firewall, if I'm opening SSH port from outside, then this is going to be the dynamic port as a source. My target port is going to be the port 22. And the moment this connection is allowed, the outbound connection is dynamically formed. And it is going to keep on connection track. So for example, let's take a TCP connection where you see the SYN, SYNAC, and ACK. So it must see the SYN before it is going to pass SYNAC. A fourth type of firewall is next generation firewall, or you can call it NGFW. Is a type of firewall that combines traditional firewall capabilities with additional feature and technologies to provide enhanced security and deeper visibility into the network traffic. NGFWs are designed to address the evolving threat landscape and the increasing complexity of modern network. And these can be the on-prem offerings, or there are firewalls provided by cloud providers like Azure firewalls. Those are also offering next generation firewall features. The feature set which comes with these firewalls are stateful packet inspection, application awareness, intrusion prevention system, URL filtering, user and identity, and content filtering. That gives you a overall control to tackle your advanced threat protection. Another very critical concept is firewall zone and security labels. And these are the concepts commonly used in network security to define different area of trust and enforce security policies within a network. While these terms are often associated with Cisco ASA firewall, they are also applicable to other platforms as well. So let's first understand what is a firewall zone. By definition, a firewall zone is a logical grouping of network segment or interfaces with similar security requirement and a level of trust. So you can divide this firewall into different zones. You can call it this is first zone, second zone, or the third zone, and you can name it as well. So first, this thing I can call it, let's say outside. This I can call it DMG, and this can be my inside. And the purpose for zones is to allow administrator to define security policy that controls the flow of traffic between different area of network based on their security posture and the level of trust. Security labels, if you have ever configured a Cisco ASA firewall, you might have given some sort of the numbers to those particular interfaces. So in a typical configuration, basically the traffic originating from trusted internal network inside zone, that is going to be your security label 100. And outside, let's say this is security label 0 and this is 50. So from inside, I can access outside. I can also access this. But when I initiate from low level to higher level, you need a explicit firewall rule. If there's no firewall rule, there's not going to be a traffic allowed from this particular zone to inside. Thank you for watching, and I will see you in the next section.